Solving quadratic equations by factoring. So we have learned how to factor and been practicing factoring quadratic trinomials of the form x squared plus bx plus c with a leading factor other than 1 and a difference of squares. Let's just spend a moment and practice this up a little bit more. Factor completely. So I'm going to let a be x plus 5, and I'm going to solve a simpler problem, right? Which is factoring a squared minus 2a minus 48. Two numbers multiplied to 48 differ by 2. A minus 8, larger one, is negative. A plus 6. Okay, but really it's not an a, right? It's an x plus 5 minus 8. Shouldn't have an equal sign there. That's actually equal to this. And x plus 5 plus 6, that's equal to x minus 3, okay, plus 5 minus 8. We're removing the brackets, nothing special to do. And x plus 11. Make that a thick one, an 11. Okay, same deal. Let b equal to x plus 7. 3b squared minus 8b plus 5. Okay, 3b, it's prime. The first factor is, or the first number is prime, so it can only be 3b and b. This can be a 5, so we get a 5 and a 1. This is a plus, they're opposite signs. So I'm going to go minus 1, minus 5, or sorry, opposite sign. They're the same sign to give me the plus. 3b squared minus 3b minus 5b is minus 8b plus 5. Again, do the check. So b is 2x plus 7. Keep that in brackets because I've got to multiply it by 3. And b, again, 2x plus 7. And just get in the habit of putting it in brackets so that if there is something in front, that'll make life much easier for you. So 6x plus 21, 6x, I got plus 21 minus 5, will be 6x plus 16. And here, that's a 1 over here, right? So we've got 2x plus 6. Okay, common factor here, they're both even, so 2 goes into that, giving me 3x plus 8. And here, 2 goes into that, giving me x plus 3. 2 times 2 is 4, so this is equal to 4. We got a 3x plus 8 and an x plus 3. Are these equal? If you expand this and you were to square this trinomial up here, remember we're going to get 3 terms. If we do that, it'll be 4x squared. That's 14, double it, we get 28x, and then we've got a plus 49. And if you wanted to do that, you should see that these two were equal. Last one, let's see if we can squeeze the last one in here. I'm just going to divide, give me some space there. This is a difference of squares. This has a square root. There'll be a 3 and an x minus 2. That's the square root of the first term, minus, or sorry, plus, I always do the plus first, plus 3y minus 5, and then a 3, and an x minus 2 here, and now the minus 3y minus 5. I'm not sure if I'm outside my recording area or not, but if I am, well, we'll bring that back in. So 3x minus, so bracket, this will be 3x minus 6 plus 3y minus 5. This will be bracket 3x minus 6 minus 3y, and then a plus 5. Collecting down, we have 3x plus 3y minus 11. And a noisy background here, but I'm going to persist. 3x minus 3y minus 1. So those are the factorizations of that. I'm going to pause. We'll scroll down a little bit and take a look at what's next. Okay, let's take a look at what we've got here. A quadratic equation is an equation that can be expressed in the form ax squared plus bx plus c equals 0. Remember with a quadratic function we had y equals? With the equation, it's equal to 0. When an equation is written so that one side of the equation is equal to 0, we can use factoring and the zero product property to solve the equation. The zero product property states that if the product of two numbers is 0, really two or more numbers, then one or both of the numbers must be 0. So that is, if m times n, two things multiplied together, are equal to 0, then either m is equal to 0 or n is equal to 0, or both, meaning, lost my pen, both, the way we could say that is m is equal to n is equal to 0, right? So in other words, let's get something that is equal to 0, one of these. 1, solve by factoring. First step, get everything together on one side. So 2x squared, move the 5x over, minus 5x. Subtract 1 from both sides, gives me plus 2 is equal to 0, right? We must have this thing equal to 0. Now we factor 2x, x, right? The only way we're getting a 2x squared. The 2, the only way we're getting a 2, it's a plus. Both signs here are the same, and because of the minus there, they're both minus. I need to get a 2. The factors of 1 and 2 are 2, and that's equal to 0. It's guess and check, so we guessed. It's now time to check. 2x squared minus 4x minus 1x is minus 5x plus 2. So we're good. Now the zero product property says either 2x minus 1 is equal to 0 or x minus 2 is equal to 0. If this is true, then 2x, we're going to solve for x. 2x is equal to 1 and x is equal to 1/2, or x minus 2 equals 0, add 2 to both sides. We're solving for x, we're isolating the x, so x is equal to 2. So solve by factoring either x is equal to 2 or x is positive 1/2. Let's just check this out. If x is 2, 2 squared is 4, times 2 is 8, plus 3 is 11, 5 times 2 is 10, plus 1 is 11, and we can see that x is 2 does in fact solve this. And similarly, if we checked 1/2, we would also see that it solved. 3x squared equals 5x. Okay, solving by factoring, we have to set aside to 0, so we're going to subtract 5x. Factor two terms. Well, first thing with two terms is, does it common factor 3x minus 5, or is it a difference of squares? This is not a difference of squares, so we have common factoring. So this says either, the first factor, either x equals 0. Okay, so if x is 0, you'll see this is true. We'll get 0 equals 0. Or 3x minus 5 is equal to 0. So 3x is equal to 5, and x is equal to 5/3. So if x is 5/3, this will be true. Okay, and you can verify that for yourself by substituting in 5/3. Okay, 2 more to do, a little bit more space here. 3, x minus 2, x plus 1. So what we're going to have to do here is we're going to have to expand this, simplify it, multiply it by 3. We're going to have to simplify this. We're going to have to move the 4 over. So let's get busy. There's a bit of work to do here. So 3. This simplified. Okay, we get x squared. We've got to FOIL this, right? Plus 1x minus 2. Plus 1 minus 2 is minus 1x. So we just write minus x. And minus 2. Minus 2 times. We're going to square this binomial. Now the quick way to square a binomial, square the first term. X squared. Multiply the 2 together. Gives me minus x. Double it. Minus 2x. Square the last term. Plus 1. You multiply two binomials together, you're getting 4 products, which often collect to 3, The only time they collect to 2 is if it's a difference of squares, right? If you have conjugates, if that's x minus 2 and x plus 2, we'll only end up with 2 terms. Minus 4 equals 0. Okay, keep going. Oops. You know what? I do not want an equal sign in front here. Okay, because I already have an equal sign on the line, so I'm going to write it like this, and then that's equal to 0 because I've subtracted the 4. Okay, collecting terms. 3x squared minus 3x minus 6. Negative 2 here. It's going to distribute through. All these signs are going to change. So we get minus 2x squared plus 4x minus 2 minus 4, and that's equal to 0. Okay, collecting 3x squared minus 2x squared, 1x squared, minus 3x plus 4x is plus x, minus 6, minus 2 is minus 8, minus 4 will be minus 12, is equal to 0. I want to factor. This is a leading x squared, so we know we've got x's there. Two numbers that multiply to 12. Because of the minus sign, they differ by 1, so those numbers are 4 and 3. The larger one is positive, so plus 4 minus 3, quick FOIL, x squared minus 3x plus 4x is plus 1x minus 12. That's equal to 0. So either x plus 4 equals 0 and x is negative 4, or x minus 3 is equal to 0. Zero product property says one of these has to be 0. They both can't be, the different values, and x is equal to 3. So our solution is x is negative 4 will work, right? If we put a negative 4 in here and simplify this, we'll get a 4 here. Let's try it with 3 just to see what happens. 3 minus 2 is 1. 3 plus 1 is 4. So we've got 3 times 1 times 4 is 12. 3 minus 1 is 2. Squared is 4. Times 2 is 8. We get 12 minus 8, which is 4. So you can see how that verifies, and that's just sort of a quick mental check. Okay, what are we going to do here? Well, we've got 4/5 x squared. Let's subtract the x and subtract the 3/10 and set that equal to 0. So we've moved everything to one side. We have 0 over here. Now, I don't know about you, but I don't like denominators, so I'm going to get rid of the denominator. And the way I'm going to do it is to multiply both sides by 10, because 10 is my lowest denominator. Oops, minus x minus 3/10 equals 10 times 0. So I'm doing the same thing. I'm multiplying both sides by 10. 10 times this. 5 goes into 10 twice. We'll get 8x squared minus 10x. And then minus 3 is equal to 0. Nice thing about having one side of an equation equal to 0 is you can do stuff like this. You can get rid of denominators, in this case by multiplying through by 10. Okay, let's try factoring this. Now, I know that this and this will be a 1 and a 3. There's an 8 there, so it's either an 8x and an x. I'm going to go, though, with 4x and 2x. If I put a 3 here, I'm going to go with a minus 3. That'll give me minus 12x. And then if I put a 1 here, that'll give me plus 2x. That will give me that, and that gives me that. And again, that's just some experience here, right? You need to be able to factor. So however you get this, you need to be able to get the factored form. Let's just double check. 8x squared minus 12x plus 2x is minus 10x minus 3. Okay, sorry for the little extra stuff in here. Okay, so either 4x plus 1 is 0, 4x is negative 1, and x is negative 1/4, or 2x minus 3 is 0, 2x is equal to 3, and x is 3 halves. Okay, and those are our two solutions. X is negative 1/4 or positive 3 halves. Again, put them into here, either one of them, actually both of them. If you substitute it in, you will see that you get a true statement. The left side will equal the right side. Okay, let's just show that. I'm going to show you a formal verification. Okay, so to do that, I'm going to go clear myself some space over here. Just kind of erase this. And I'm going to show a formal verification just with one of the values. We'll do it with a -1/4 because really the -1/4 is kind of the more difficult of the two. So let me just erase this. So in a formal verification, what I want to do is I want to work the left side and the right side of this separately. So let me go back here. And I want to do it on the original. Okay, so forget this. We're verifying this thing here. So I'm going to say the left side of the equation is 4/5 x squared. And this is what's called a t-table. See how I've split it, and this is a t-shape. And the right side is equal to x plus 3/10. So I'm going to start here. I'm going to try x as -1/4, and I'm going to add 3/10. Now, to do this, I need a common denominator, which will be 20. So this will be -5/20 plus, and this, so I just multiply by 5 top and bottom. This will be 6/20, and we end up with 1/20. Over here, we have 4/5 times -1/4 squared, which will be 4/5 times 1/16. 4 goes into 16 4 times. That's a 1 there. And we get 1/20. The left side is equal to the right side. And that's a formal verification of the value of x being -1/4. To do it for the whole thing, we would then go back and redo this, only substituting x is 3/2. And I'll leave that for you to do if you would like. Okay, to do a formal verification. Next, number 2. Well, the 2 disappeared off the screen, but this is number 2. Write a quadratic equation with roots -2 and 5/3. Do it in this form, where a, b, and c are integers, and a is greater than 0. Really what we're looking at is, let me just pop up here, so this is visible, because we're kind of going to just reverse this process up here. You note here how we ended with x equals -1/4? Well, let's end with x equals -2. Well, I don't really want to end there. I want the factor. So what we need is all the x's on one side and 0 on the other. So this is x plus 2 equals 0. This is just sort of working this one backwards, right, ending up here. So we know that a factor here is x plus 2, right? Zero product property says we need factors that are equal to 0. This one is x is equal to 5/3, right? This is what we know. Multiply both sides by 3. 3x equals 5. We need this to be equal to 0, so 3x minus 5 is equal to 0. This is our other factor. So our two factors are x plus 2 and 3x minus 5. When we FOIL these out, we'll get 3x squared minus 15x plus 6x, which will be minus 15 plus 6 is a minus, not a plus. So let's clear that. Go back here. So where were we? 3x squared minus 15x plus 6x is minus 9x. Common factor, but minus 10. So this is the quadratic equation. Okay, and actually we're not going to do that. We know that this has to be equal to 0, so we're going to say this is equal to 0. And had you been given this to begin with, then we would have worked it the way we did here, only here we're going back up. We would factor it, and then set each factor equal to 0, and then solve for the x values. In this, we're working this backwards. We have the x value. We need to get this so that it's a factor that's equal to 0. We do that by getting a 0 on this side. So here, multiply both sides by 3, move the 5 over. We want the right side to be 0. The left side will be our factor. Okay, so that's working from the roots back to the factors. And once I have the factors, then we can get the quadratic equation. Okay, what's next? two numbers, this is not the last one, second last. Two numbers differ by 10 and the sum of their squares is 388. Determine the values of the two numbers. So we could say, let the numbers, so we need a statement. We need to define our variables. So let the numbers be x and, well, let's make the next one bigger, x plus 10. They differ by 10. So if this is 12, this is 22. Those differ by 10. You could also have used x and x minus 10. Okay, but I've chosen x and x plus 10. So these are two numbers that differ by 10, and the sum of their squares. Also, could have said this, let the numbers be x and y, so that we have two different numbers. And we could have said y is equal to, or let's do it this way, y minus 10 is equal to x, right? So they differ by 10. If I subtract 10 from y, I'm going to end up with x. So y is equal to x plus 10, right? And that's a way to get our two numbers, and I've just expressed them as x and x plus 10. And the sum of their squares, so x squared plus the sum of this number. Now this number is x plus 10, and that's going to be equal to 388. To solve this, we have to simplify this expression. We got to get rid of this as well, right? It's got to be equal to 0. So I've got x squared plus square a binomial. You get 4 products, which collect into 3. And since it's squaring a binomial, I'm just going to do it in one step. It's x squared. X times 10 is 10x. Doubled is 20x. And plus 100. Now, if you're squaring this and only getting 2 terms, x squared and 100, then you're going to lose all the marks for this, because you cannot square a binomial and end up with just 2 terms. The only way you get 2 terms is a difference of squares, right? X plus y and x minus y. But squaring a binomial, you must end up with 4 products, which will collect the two 10x's into 3 terms, trinomial. Okay, collecting 2x squared plus 20x, subtract this, minus 288 is equal to 0. We want to solve this. How do we solve? We factor. But before I do that, let's divide everything by 2. I don't need to factor the 2 out. Since the right side is 0, I can just divide everything by 2. X squared plus 10x minus 144 is equal to 0. X, and I got an x. It's a negative, so the numbers differ by 10. So I need two numbers that multiply to 144 and differ by 10. Well, 1 and 144. Nope, they don't differ by 10. 2 and 72. Nope. The numbers are actually going to be pretty close to kind of 12. So we could say, well, 12, be 12 and 12. Well, those don't differ by 10. Let's go a little bit higher. Let's see, what's higher? 16. Does 16 go into 144? 144 divided by 16. Just working on the calculator. So 16 and 9. No, those differ by 7. 144 divided by, well, let's try 17. Nope. 144 divided by 18. 18 and 8. Yes, so I had to play with the numbers a bit, but 18 and 8, larger number will be positive, so plus 18 minus 8 is equal to 0. Double check, x squared minus 8x plus 18x will be plus 10x minus 144. So this one says that x plus 18 is equal to 0, or x is negative 18, and this says that x minus 8 is equal to 0. Remember the zero product property, or x is equal to 8. If x is negative 18, then the other number is x plus 10. So the numbers are negative 18 and negative 18 plus 10, which is negative 8, or, well, if x is positive 8, then this is 10 greater, which is positive 18. So, or 8 and 18. So being a word problem, we need a few things here. And let's just review what we need to have. You need a statement defining your variables, or a diagram, or something, right? There has to be something so that I'm communicating to you, or you communicating to me, when I look at this, just what x and this x plus 10 are. We need an equation. We have the equation. We've simplified this, got it down to a quadratic, decided to divide everything by 2. Since the right side is 0, we can do that. Factored it, used the zero product property to say each factor is 0. You don't really need to state this. You can go from x plus 18 to x is negative 18, and x minus 8. You can just go to straight x equals 8. I'll allow that. But there are 2 values. Well, let's check this then, right? How do we check? Let's take the numbers and go back to the statement here. I never go back to this equation. What if it was wrong? So 2 numbers differ by 10. Negative 18 and negative 8 differ by 10. And the sum of their squares. 18 squared. Well, 18 squared is 324. And negative 18 squared would still be positive 324. Negative 8 squared is positive 64. 324 and 64 added together is 388. 8 squared, 64. 18 squared, 324, and their sum is also 388. So there are 2 possible values for the numbers. So unless the question specifically states that they must be positive, then be aware that you may have more than one set of answers. Okay, last one. An area rug has a central 5 meter by 3 meter rectangle in a mosaic pattern with a plain border of uniform width around it. The total area of the rug is 24 square meters. Determine the width of the border. This is a common type of problem. It's rugs. We could have a pool with a deck around it. We could have a picture inside a picture frame. And they all kind of look like this. So area rug has a central 5 by 3 meter. So let's just draw something in here. So we'll call this 5 going this way, and 3 going this way. And a uniform border around it. So it's x here, x over here, x in here, and x in here. And that's my uniform border. Now this lays out my variable, right? So in some way I have to communicate to you what my variables are. And in this case, x, which is the width of the border, right? What's your variable going to be? It's going to be, what are you being asked for, right? The width of the border. Okay, the total area of the rug is 24 square meters. Well, the total area will be length times width. And this width here will be 3 plus x, or 3 plus 2x. And, well, let's call that the width. Then the length is 5, and we have an x on either side here. So it's x plus 5 plus x. Isn't written very nicely in here, but this will be 5 plus 2x. And we know that the area, which is length, 5 plus 2x, times width, 3 plus 2x, is equal to 24. Expand this. We're going to FOIL this out, right? 4 terms, which we're going to reduce to 3, and I'm just going to do it. And I don't want to write equals here, right? Because I already have an equal sign. So it's 15 plus 10x plus 6x. So 10 plus 6 is plus 16x plus 4x squared. Now let's do this. We'll go minus 24 equals 0, right? The way we're solving is we're always getting the right-hand side equal to 0. Okay, let's simplify. 4x squared plus 16x. And I always like my x squared first, then my x. And we've got minus 24 plus 15, which will be minus 9, is equal to 0. No common factor here, right? 4 and 16 have a common factor, but the 9 throws a wrench in there. So let's put down our 2 sets of brackets. I know that I have opposite signs, right? So going to, what am I going to do? I'm going to guess. So I'm going to say, what if we have 2x and 2x? Is this a trinomial square? I'm going to ask that first. This has a square root of 2x. This has a square root of 3. 2x times 3 is 6x. Doubled is 12. So no, it's not a perfect trinomial square. So maybe it doesn't actually lead with 2 and 2. So I'm going to change that. Let's make this a 4. If it's bigger and darker, then let's just make that a 1. So 4x and 1x. 200 multiplied to 9. 1 and 9 or 3 and 3? So if I put a 3 here, I'll get a 12, and a 3 here, I'll get a 1. But 12 and 3 don't differ by 16. If I put a 9 here, I'll get a 36, and then a 1 here. So those won't give me a 16. So that won't do it. Well, maybe it is 2x and 2x. So how about I put a plus 9 and a minus 1? And actually, I think that's going to do it. So never mind changing your mind. Okay, that's a guess. Let's check it. We got 4x squared plus 18x minus 2x is plus 16x minus 9. Great, that's exactly what we want. So this says 2x minus 1 is equal to 0. 2x is 1. X is 1/2. There's actually a very easy way to do this. I'll show you in a sec. And this one is 2x plus 9 is equal to 0. 2x is negative 9. X is negative 9/2. Well, that's not going to work. We can't have a width of negative 9/2, right? A negative width. So I need to find this, but then I need to reject this answer. So I'm going to cross it off, right? To communicate to you, yes, I know how to solve this. One of the solutions came out as a negative, and I cannot have a negative width for a border, right? If we were just solving this, that is one of the solutions. But in the context of the question, that is not one of the solutions. So that means that x is 1/2. And let's just state it here, the width of the border is, and I'm going to go decimal on here because 0.5 meters. Okay, let's check that. Let's go up here. What if this is, what if this is 1/2 meter and 1/2 meter? Then those two together are 1 meter, and this thing will be 4 meters this way. And 1/2 meter and 1/2 meter is 1. This will be 6 meters this way. 4 times 6 is 24. That's your check. Your check is to go back up, forget your equations, look at the scenario, look at the situation, put the numbers in, and see if you get the correct answer. Okay, one last thing, because we haven't yet hit 40 minutes. So when I solve 2x minus 1 equals 0, the easy way is just to go x equals 1/2. So how do I do that? What I do is I take the opposite sign of this and put it over this number. Why? This negative 1 is going to move over and become positive 1 and then be divided by 2. So that's the quick way. How about 2x plus 9 equals 0? Okay, same deal. The 9 is going to move over and become negative 9. And then I'm going to divide by 2. So x is negative 9 over 2. So when you're doing these, you don't need to show me this step here. You can go from 2x plus 9 equals 0 to x equals negative 9/2, right? And 2x minus 1 equals 0 to x equals 1/2. But, do yourself a favor, go back to the original scenario, put in the 1/2, check it out, make sure you get the 24 square meters for the area. Okay, and let's just scroll down. We are done with this example.